Hi everyone, I hope you're well. So this lecture is in continuity with the securing storage infrastructure. So if you remember the last class we have discussed, we were discussing this authorization and authentication in identity and access management in storage infrastructure. And here is the difference between authorization and authentication that I had explained. And we were discussing these topics in detail. We have already discussed Windows ACL access control list in Windows, Unix permissions, which is read, write, and execute for user groups and others, and then O authorization protocol. Then we have discussed multi-factor authentication, Kerberos, CHAP, and OpenIDs left in this topic. So this was multi-factor authentication. You'll remember this once you look at the diagrams. This was O authentication protocol. I'd given you example of Twitter in this case, and then is the Kerberos process. Okay, next is CHAP, Challenge Handshake Authentication Protocol. So this provides a method to authenticate between the initiator and the target. Here you can see in the initiator, we have the compute system having hypervisor application OS and VMware, all those virtual machines. On the target side, we have iSCSI storage system. Now the CHAP can be one way or two way. Okay, so here in this case, in this example, you can see the CHAP is one way. So what is the first step is the initiator will firstly initiate the login to the target, right? So now initiator wants to log in to the target. Now target has to authenticate whether the initiator is authenticated to access it or not. For that, initiator will send a CHAP challenge to target will send the CHAP challenge to the initiator. Just a minute. Right, so what it will is this initiator will take the shared secret key and using one-way hash function which computes MD5 algorithm, it will by applying that hash function, this initiator will convert that key into the hash value. Actually the CHAP challenge that this target sends to the initiator can be up to 28 bit key that in target sends to the initiator, right? So after applying the hash function, it will generate the hash value that it will return to the target. So what target will do, target already has that CHAP challenge that it has sent to the initiator. So this target will use that to compute its own hash value, and then it will compare the value with the one that it has received from the initiator, right? If that matches, then the authentication process is done, right? So that particular initiator is authenticated to access this target, right? And then the authentication is acknowledged and sent to the initiator, and then it can access that particular target. So this is challenge handshake authentication protocol. Now, so this was the challenge that is sent by the initiator to the target, and handshake by the target to the initiator. So this is the example of one-way CHAP. Now what happens is when initiator also wants to authenticate that whether the target that it is requesting to log in is the same or not. In that case, the same process will be done by the initiator also. So initiator will send the CHAP challenge to the target, right? And target will have its shared key, and that it will apply the hash function using MD5 algorithm, and then it will compute the hash value. That hash value will be sent back to the initiator, and then the acknowledgement is sent. right? So that is the two-way authentication when initiator and target also want to authenticate each other in the process. Next is OpenID authentication. Now, OpenID is the open standard for authentication in which an organization uses authentication services for an OpenID provider. So any company can rely on the third party organization for the purpose of authentication, right? So which is OpenID. Like suppose this user wants to access a particular site. Now that site needs user ID and password. Now that site is relying on some third party organization, which is OpenID, right? So means this particular user has to be first authenticated by the OpenID, okay, the service, the OpenID, right? Then only it will be able to access that particular site, right? So here what do we have is, here we have the OpenID login request, which that particular service provider is relying on. So this service provider is the website owner, right? So you can take any dummy website like www.abc.com. That particular website does not has any control on the authentication process, right? So what happens is when this user login request using OpenID, right? Because this person has already created an account using the OpenID provider, right? So what will happen, that particular service provider who is not having own authentication control, it has to first send the request to the OpenID provider, which is the identity provider to that particular website, right? Next in that, the authentication request is redirected to that. Then the consent to profile sharing is given to that particular user, which creates an ID with one of the OpenID providers, right? Once that is done, then the authentication response is redirected to the organization providing services, means to that abc.com website, which that user is trying to serve. And as I've said here is, this particular service provider is not having any authentication control. So this OpenID provider maintain all the user credentials and enables relying parties to authenticate users. So in this case, in this example, we have one relying party. So there can be multiple. This OpenID provider serves multiple websites, multiple relying parties. Okay. So this is the kind of authentication in which the service provider rely on some other company, some other organization. Okay, then in the key security controls, we have the role-based access controls, network monitoring and analysis, firewall, intrusion detection, adaptive security, VPN. Then we have the zoning and SNS discovery domain, and then port binding and fabric binding. So these are very small topics. You will get these topics easily. Okay, so this is role-based access control. I've already discussed about this in one of my previous lectures. So using this, we can restrict the access to authorized users based on their respective roles, right? In an organization, there can be administrators, there can be designers, there can be stakeholders, users. Okay, so we are providing privileges to access a particular drive, folder, file according to the role. Okay, there might be the case that administrator is having to perform is having the privileges to perform read, write and execute on a file, but stakeholder can only read or execute, cannot write in, or user can only have the read or execute cannot write in. So these are the role based access control which we provide according to the role, so that a person according to the role can access a particular file, right? So this separation of duties ensure that no single individual can both specify an action and query in out. So according to the duties, according to the roles, so we can ensure the actions that are being performed on that particular file or pool or directory. Next, we have the network monitoring and analysis. So basically what we want to do here in this is we want to monitor the network, right? So that there are no threats, and we also check the vulnerability of the network, whether uh, it can catch some sort of threats, or it can allow the packets to the network that should not be able to enter into that network. So in this we have the active and passive. Basically, in case of active, the data between the two endpoints are monitored, okay, like from one host to another host. However, in case of passive, any device is monitored or any link is monitored in case of passive network monitoring analysis. So that what are the controls herein? Firewalls, IDPS, intrusion detection and prevention system, and network analysis or forensic systems. So let's understand in this what is firewall and demilitarized zone. So firewall is the security control, so which examine the data packets entering into the network, right? And there are some set of rules defined by the organization, so that we can allow packets according to those rules only, right? So according to the rule, if that particular packet is not according to that, so we can deny that packet, and if it is according to that rule, we can allow it. Now, so this can also be applied to the IP addresses, right? So if we want to receive the packets from certain IP addresses from certain hosts, we can allow the packets from there, otherwise not. So rules can be anything, like what kind of network they want to enter, what kind of packets they want to enter into their network. So here we have internet, which is external network. Here we have the internal network, and this is the demilitarized zone. Uh, this contains all those servers which we want to access using internet. So here in this, whatever resources are lying in this demilitarized zone can only be accessed by using the internet facility. Now here in the internal network, that's fine, anything lying in the internal access can be easily accessed by the users over there, right? Now what happens is, so if this server is lying in this demilitarized zone, so when someone tries to access this server, so this will ensure the security for this particular server, that which packets do we want to traverse or not, right? Here we have the firewall, here we have the firewall. So this firewall is providing protection against this internal network, and this one is providing protection against this internet, okay, external network, right? So it can be deployed physical or virtually, right? Firewall can be deployed at the network level, compute level, hypervisor level. All of us know that what is the hypervisor, the networks, and the compute, the computation power, right? So can use different parameters for traffic filtering according to the rules. How do we want to filter out the packets? Filter out any proxy server or any other. So next is intrusion detection and prevention system. So this is a security tool that automates the process of detecting and preventing events that can compromise the confidentiality, integrity, or availability. So this is what we want. We want to maintain that CIA triangle of the information security, the basics. So the techniques can be the signature based detection techniques, scans for signatures to detect and Intrusion. So basically the signature doesn't mean your own signature, your own handwritten signature. So in this case also algorithm is applied at the back end, and that encrypted signatures are verified if we want to find out that whether the host which is trying to access any resource, whether that person is authenticated or not, right? But the signature based detection technique effective for only the known threats, like where we have the idea that this can be a threat, so that we can apply that technique, signature based detection technique, to find out. Next is the anomaly based detection technique, scans and analyzes events to detect if they're statistical different from the normal events, has the ability to detect various events. So what happens is when something different happens in an organization from the normal events, so this can be suddenly this suppose there were, like on a daily basis, suppose there are 1,000 views on a blog, right, or on any article, right? Suddenly the views go down maybe to 100 or 200, right? So this kind of behavior which is different from the normal, so that can make the person think, the company thinks that something fishy is going on, right? So using that we can find out, basically we want to detect if something someone is trying to compromise confidentiality, integrity, or availability. The example that I've given you is called as the uh, compromisation of availability. So this is called as denial of service attack, where we limit the resources to the users who are using, so that they're not able to access that particular resource, right? So this was about the other technique. Then we have the adaptive, a control that integrates with the organization's stand-alone controls such as IDBS and firewalls, right? So in this case, what we identifies and block anomalies. So adaptive control system, any sort of anomaly that is lying in the system, it's basically identify and blocks it, right? So next, we have the parameters. So that can be the behavior profile of the parameter, device related profile, from which device that person is accessing, types of browser being used, plugins used in the browser. So some sort of these parameters can be used to identify that there is some anomaly in about the user who is trying to access their site or resource, right? So basically this is based on finding out the behavior, right, to detect the fraudulent activity. Next, we have VPN, virtual private network. So this is about the extending users' private network across the public network. What happens when someone is having his own network and wants to extend it across the public, right? So enables to apply internal network security manager policy management policies over the VPN. So how one can establish a VPN is basically we want to authenticate any person who is trying to access the private network, right? First is remote access VPN connection. Second is site to site. So in this, any remote client initiates a remote VPN connection request. Okay, when that is authenticated by the VPN server, then only the access will be granted to organization's network. On the other hand, site to site means when remote site initiates a site to site VPN. So this was about the client initiating a VPN, and another thing is any remote site can also initiate, and a VPN server will authenticate whether that site is authenticated to access that organization's network or not. Next, we have the virtual LAN, virtual SAN, storage area network, right? So this ensures the security by providing isolation over the shared infrastructure. Means whatever is the shared infrastructure, suppose we have one server here and we have two host here, initiator here wants to access that particular server. So we want to restrict this particular server to access the resources of this particular server, right? So for that, we can go ahead and uh, implement zoning, right, which provides additional level of security within the virtual SAN, right? This has already been discussed before in detail. Now, the zoning logically segment node parts into groups. Suppose we have the nodes and we create different zones for each node so that the communication occur among node parts within the group. Okay, like if I have one server over there and I have two nodes over there, if in the one zone I have one node and the storage array server, then the communication can occur in that zone only, right? If another node is occurring in another zone, then that will be able to connect according to the nodes which are present in that zone only. So worldwide port number based zoning prevents unauthorized access when the node ports are re-cabled to different fabric ports, right? So this also reduces the risk of spoofing, someone causing some malicious act uh, on any of the port can be on the host. So in this case, what can happen is someone enters into that particular area, like where one node is accessing the storage array. So that particular server can behave that that server is node only, so that it can access that node's storage, right? So someone can mimic some other host, right? Next is ISNS, discovery domains, right? So this is Internet Storage Name Service domain. So this functions the same way as fiber channel zones, right? So in this, we create the functional grouping of the devices. And in that case, the device in the same functional group according to this storage name service protocol, they can communicate with each other. So this already has been discussed in your third unit. As I've told you, if anyone is having doubt in these topics, I can elaborate. So you can, by today, what you can do is you can go through your unit number 3, okay, because that unit is very large. If in any of the topic you are facing major problem, major issue, you're not able to understand, you can tell me those topics so that we can discuss. Next is the port binding and fabric binding. So this means that we should not allow all the ports open at all the time. Suppose if one HBA is having 2 ports, if one node is using HBA having 2 ports, we should not leave both of those nodes open, right? At one time, disable the ports which are not being in use, so that particular port can be vulnerable to any sort of threat, right? So fabric binding also ensures that all the fabric which are participating in the network should only be enabled. Rest of the fabrics can be disabled, because whenever we are implementing these networks, we tend to have redundant fabrics in order to ensure the availability. So the other redundant fabrics should be disabled at one time. Next we have is securing hypervisor and management server, VM OS application hardening. Then we have malware protection, mobile device management, LUN masking, encryption and shredding. Okay, this is securing hypervisor and management system. Okay, so when we are using the virtual technology, what we should need to do is we should need to install security critical hypervisor updates, right? Which are the secure hardened hypervisor using specifications provided by CSI and DISA. So hardening means implementing proper security measures so that no malicious software, no malicious user can attack it. So hardening basically means securing. against any kind of malicious attack and making it less vulnerable for the attacks, right? So next is so these are the basics that you already know: restricting core functionality to the selected administrations, right? Next, we can encrypt network traffic when managing remotely, right? So there is always a threat. There is always a threat when we are using any network traffic across remote. Deploy firewall. All of you know what a firewall is. Next is rotate or delete log files when they reach a certain size, because log files contain a very information that can contain all the actions that are being performed in any organization. So either rotate it or delete it or change the location of those files or save at a secure place. Next is VM hardening, OS hardening, and application hardening. As you already know, hardening is securing a system so that it's less vulnerable to the threats. So this is much clearer now. Virtual machine hardening means process used to change the default configuration of the VM, right? So that means tuning configuration of VM features to operate in a secure manner. What we want is we just want to ensure the security in the VMware. So what can be done? Tuning configuration: VM templates must be hardened to a known security baseline. All the templates that we are using in the VM machine must be hardened, must be secured, right? So various scenarios can be implemented again that are mentioned here. Next is OS hardening. So CIS means Center for Internet Security, and DISA is Defense Information System Agency, these protocols. So we can configure OS hardening according to this protocol, these protocols, right? Whatever files are not in use, not applications not in use, we can delete those. We should install the current operating system updates, right? So there can be more security measures. So we need to update the operating system accordingly, right? Perform vulnerability scan and penetration in order to ensure if any of the network component is becoming vulnerable for the threat. Application hardening. So application hardening ensures that our application is secure enough and not vulnerable for any kind of virus. And this also include managing the child process, which is process spawning control. We have the parent processes, child processes, all are ensured against any kind of malicious act. Then we have the malicious software protection. Malicious protections of malware protection software is all those software that uh, detects, prevents, or removes any malware programs. A very simple example of this is the antivirus programs that you install on your systems, right? So what else? Signature based detection techniques that we have discussed, and disallows any unauthorized modification, whatever areas are sensitive, vulnerable, unauthorized. So all the topics are same, just written in different contexts. So you should just know all the basics about CIA, your risk triads, right? And then you should be knowing about the uh, authorizations, authentication, right? And what need to be performed in order to ensure the confidentiality, integrity, and availability of the system, right? So everything is just revolving. All these topics revolve around each other. So next is your mobile device management. So this is something I think you already know. So here we have as this client, right? So what happens is MDM, mobile device management authentication server, authenticates the devices. Like your device that you're using is authenticated by this server, right? And is noted by this server when your system, which is authenticated, when try to access something remotely, right? So that is allowed through the firewall. But when some other unauthorized devices, no matter MDM client is installed, when tries to access that is not allowed by the authentication server, right? So this is a demilitarized zone. So this is an example where firewalls have been implemented on both the ends, and this is the server which need to be accessed using internet only. So that's why we have firewall on one end, firewall on another end. Next is LUN. So means how do we want to secure whenever some hosts are referring to the uh, server array, storage arrays. So this logical unit number provide protection against any of the unauthorized access to the storage. Plus LUN masking means this provides a unique address which can be used by the host to access their particular logical unit number. Next is the data. How do we want to store the data, which is data encryption? Means we do not want someone to steal our data if our data lies in the state which it actually is. So rather encrypt the data, change the form of data by applying some hash function, and then store the data somewhere else to protect it against any kind of tampering, media theft, and sniffing attacks. Now in that case, you need to secure the key. That's very important because only key can be used to decrypt the data. Okay, next is data shredding. If your data that you have stored somewhere is not required, data shredding can be carried out in order to completely destroy the data in such a way that it is not recoverable. So some shredding algorithms can be used, right? So sometimes when you have recovered all your data from the backups and replica, so you can shred all the copies of data which are lying on some remote location in order to ensure that the data cannot be stolen by someone else. So this was the end.